All right, let's have a look at this question. This question is taken from June 2017, question number 4. The question says the function f is defined as f of x is equal to 1/3 x minus 2, where to I find the value of f of 3 plus f of minus 3. All right, let's begin. All right, so f of 3 would be equal to, when someone says to find f of 3, really what we do is that in f, wherever we see x, we're going to take out x and put 3. So it's 1/3 of x, which is 3 minus 2. All right, so 3 cancels 3, leave 1, minus 2, and 1 minus 2 is minus 1. All right, let's find f of minus 3. F of minus 3 is saying to me that in f, wherever I see x, I must take out x and put minus 3. So it's 1/3 of minus 3 minus 2. So this cancels that, minus 1. So now what we have is minus 1 minus 2, which is minus 3. Therefore, f of 3 plus f of minus 3 is the same as saying minus 1 plus minus 3. Alright, so this is the same as saying minus 1 minus 3, because a positive times a negative is a negative, and minus 1 minus 3 is minus 4. Alright, and the rule there is saying that if the signs are the same, you must add and keep the sign. So f of 3 plus f of minus 3 is equal to minus 4. Alright, the second part of the question. F of x, calculate the value of x for which f of x is equal to 5. Alright, so we're told that f of x is equal to 5. But f of x is 1/3 x minus 2. And this is equal to 5. Alright, let's solve this equation for x. We're asked to calculate the value of x for which f of x is equal to 5. Alright, negative 2 goes over and become positive 2. So what we have is 1/3 x is equal to 5 plus 2. 1/3 x is the same as saying x over 3. Multiplying by a third is the same as dividing by 3, is equal to 7. If you have one fraction is equal to one fraction, what we can do is we can cross multiply. Therefore, 1 times x is x is equal to 3 times 7, which is 21. So if f of x is equal to 5, x is equal to 21. Now, next we're asked to determine the inverse function of f inverse x. All right, let's start off with f of x. F of x is equal to 1/3 x minus 2. All right. The first step in finding the inverse is step 1. We're going to write the defining equation. So we're going to take out f of x and put y. Y is equal to 1/3 x minus 2. Step 2, we're to interchange x and y. That means that wherever you see x, put y, and wherever you see y, put x. So x is equal to 1/3 y minus 2. The third step is to make y the subject of the formula. So that means I need to have y alone by itself on one side. So negative 2 goes over and becomes positive 2. I have x plus 2 is equal to y over 3. Remember, multiplying by a third is the same as divide by 3. Now that I have one fraction is equal to one fraction, to remove the fractions, I can cross multiply. So 1 times y is equal to 3 times x plus 2. So this is step 3. Step 3 is to make y the subject again. Alright, step 4 is to write in function notation. So we're going to take out y and say f inverse x is equal to 3 into x plus 2. Alright. Alright, this is the B part of the question. And this says the graph below shows two straight lines, L1 and L2. Line L1 intersects the y-axis at 0, 1, and line L2 intersects the y-axis at 12, intersects the x and y-axis at 12, 0, and 0, 6, respectively. Alright, so here's what we have to do. The first thing we're asked to do is that we're asked to calculate the gradient of line L1 and L2. And let's go back to our diagram a little. To find the gradient of a straight line, you need to know two coordinates, the coordinates of 2 points on that line. Alright, this point here, which is the point 2, 5, is a point on both lines. So 2, 5 is a point of intersection on both lines. It means that the point 2, 5 is 1 point on the two lines. Another point on the line L1, well, this is a point here. This point is on L1. Let's determine the coordinates. The coordinates of that point are 5 and 11. So this is the point 5, 11. So to determine the gradient of a straight line, we need to know the coordinates of at least 2 points on that line. I'm going to call this point x1, y1, and call this point x2, y2. Alright, remember that the point 2, 5 is common to both line L1 and L2, so I need to know at least 1 point on the line L2. Here's a point. There's a point here. This point is on L2, and this is the point 8, 2. Alright, so I'm going to call this x2, y2. Alright, so 2 points on L1. So we're looking at the line L1. And 2 points on it are 2, 5, which is the point of intersection of the two lines. And the point, I think, the next one is 5, 11. Remember, I call this point x1, y1, and call this x2, y2. The gradient m is equal to y2 minus y1 over x2 minus x1. So this becomes y2, which is 11, minus y1, which is 5, over x2, which is 5, minus x1, which is 3. So m becomes 6 over 2. Sorry, this shouldn't be 2. It shouldn't be 3, it should be 2. So this is 5 minus 2. So it becomes 6 over 3. So the gradient of L1, M1 is equal to 2. Now let's find the gradient of L2. All right. Now the line L2. Now 2 points on the line L2. Well, the point 25 is common to both lines. So this is x1, y1 is a point of intersection of L1 and L2. And I believe another point on line 2 is the point 8, 2. All right, this is x2, y2. So m would therefore be equal to y2, which is 2, minus y1, which is 5, over x2, which is 8, minus x1, which is 2. So the gradient m2 would be equal to minus 3 over 6. The gradient m2 would be minus a half. All right. So back to the diagram a little bit. We should have expected the gradients that we got, or at least we should expect that the gradient of L2 would have been negative, because in moving from left to right, L2 is sloping down. And we should also expect the gradient of L1 to be positive, because in moving from left to right, L1 is sloping up. All right, so we got positive gradients. So the gradient of L1 is 2, and the gradient of L2 is minus a half. Next, we're asked to determine the equation of the line. We're asked to determine the equation of the line L1. Now, there are two things you need to define or to determine the equation of a straight line. You need to know the gradient of the line, and you need to know the y-intercept. So we're looking at the line L1. The gradient of a straight line is in the form y is equal to mx plus c. That's the general format. And to define the straight line, I need to know the gradient m, and I need to know the y-intercept c. We already know that the gradient of L1 is 2, and we know that the line L1 cuts the y-axis at 0, 1. So c is equal to 1. So the line L1 is the line y is equal to m, which is 2x plus c, which is 1. The equation of line L1 is y is equal to 2x plus 1. L1 has a positive gradient, and it cuts the y-axis at 1. So here, this is the gradient, and this is the y-intercept, which is 1. All right, here we're asked, what is the relationship between L1 and L2? And we're to give a reason for your answer. Well, the gradient of L1, M1 is equal to 2, and the gradient of L2, M2 is equal to minus a half. If we multiply the two gradients, we're going to get minus a half times 2, and this is going to give us negative 1. Now, therefore, from that fact, I can say that lines L1 and L2 are perpendicular lines. And this is because the product of their gradients is -1. So if the product of the gradient of two lines is -1, the two lines are perpendicular to each other.